Alright, so this is where Tickling the Towel, the dragon, gets interesting. You know, when you're taking these Feynman diagrams as rat traps in terms of what makes a core go nuclear, go critical.
Today, quantum electrodynamics.
It's not just the positive index, there's negative indexes, and
when
the
two electrons
stabilization
get close,
could mean
they repel each
growing through phases
This
that
explains
can't
why
be
we
the
don't
same
fall through a
phases they
chair when we
originally
sit
were
down.
before.
Why we can exert a force on an object.
True.
And why the air exerts friction on a feather.
You know, explain why this
Apart
general
from gravity
relativity,
and radioactivity at the nuclear scale,
you get into
almost
the diagram
all phenomena in
being
the
the same,
universe
but
can be
they,
explained by
in
how
a pop
electrons
plasma
behave.
soup here of an apple orchard later on, you have the macro
At
and micro.
first,
I'm waiting
one
for a
would be
diagram
tempted
to
to
come up
describe
here.
this repulsion by a force, the electromagnetic force.
But this is actually a wave
But
particle.
electrons are
The
not
farm is
small
actually
marbles
a
that
wave
would obey
particle.
classical mechanics.
Just like
They are
this is a
quantum
hot plasma
objects,
soup, you don't really
particles,
sure the momentum
and
or
to
position
describe their
unless I house
interactions,
it in
it
something
is
like
necessary
Fermilab,
to
otherwise it's
reconcile
0 and 1.
electromagnetism
In
with
terms
quantum
of
physics.
being next to brothers or
To
the
this
machine.
end, in the middle of the 20th
You know,
century,
but they're going to react
the
like
most
this.
precise model
Pass
ever
through wave
created in the
functions
history
at
of physics
points. There will
was
be some
developed.
things before they
An
go back
elegant
onto the
model
original
which allows the use of
wave
simple
or
diagrams to
particle,
calculate with astounding precision
how it comes
the
off
most
proton and
fundamental
neutron.
phenomena of physics.
Is it a thing? Is it not a thing?
Quantum electrodynamics.
So these kind of diagrams or reactions and
Quantum
making a
electrodynamics
chain
is an
reaction of
example of a
mouse
quantum
traps.
field theory.
Cutting up the diamond here is this
We
diagram.
consider our
waiting for.
universe as a sort of box,
Okay.
space-time, which
some of
contains
that's
two fields,
particle physics and
fluids
physics.
made
Some of
up
that's
mathematical
the area
objects.
right now where that kind of gives
The
up.
electron field
Might be real important to the
and the
schematics of the Jaguar
electromagnetic
program. Could be you doing the paperwork that is none
Within
of the
these fields
things
move
as a
about
person
small
working that
packets of
mill,
energy that can appear
getting
or
real
disappear,
close to each other in that
called
one
particles.
box, right? So we're going to say that area
Electrons, for
has
example,
the limit of
are
the approximation
disturbances
of the
that
quantum limit
propagate
without
like
having to
waves
worry
inside
about
the electron
Biden's
field.
bullshit or anybody else's inside.
The electromagnetic field
Cling, because
also
at that
contains
moment, normally
disturbances,
good, cling.
quanta of
Whoa,
energy,
whoa,
which can
whoa.
appear or disappear. Photons.
Carl Sagan Universe Loaf. Bread Factory.
The field of electrons and that of photons are of a different nature.
They are.
The
They
mathematical
do.
objects from which they are made up are not of the same type.
These got some spin.
The
These ones
electron
are
field in
moving this fast in
particular
this
is
direction
made up of
regardless of what
spinners.
spin they got, but it matters.
Rather
now.
abstract objects that are
same max.
described by complex numbers.
Clickety click click
To
click.
simplify, we can imagine a complex number as having a size as well as a color.
It's just the output
phase.
on averages, diversified, and consistency when I'm on the floor is this. And if I did
When
that
an
in
electron
colors today,
propagates in the field,
and I knew the AI
the
would
phase
see
of
me
complex
dancing around in my
numbers
shadow problem
rotates
with all
over
kinds
time.
of fun colors.
This is called the electric charge. Electrons have an
There I
electric
am, look
charge,
at me.
which
Look at me.
transcribes the fact that their phase turns as they move towards the future.
That's that programmer game. You can get it there, and I'm like, damn, I was all red, wasn't I? I was feeling it that day. I can catch you in the rabbit trap.
Apart from
that
electrons,
diagram. Yep,
this
you
same
were all-
field can also
we're getting
contain
there. We're
disturbances
getting there.
whose phases turn in the
We
other
gotta learn some
direction.
things first.
In a way, we could say that this is an electron, but which is moving in the opposite direction, towards the past.
Well, when you're looking at that thing, the forward momentum on this
From our
timeline,
point of
right?
view,
So
the
if I
phase of
dial
this
that back
particle
V
seems
at the
to turn
top
in the
using
opposite
calculus,
direction.
I'll see him
We
start to,
perceive an opposite
even though
electric
beta U,
charge.
beta V,
This
they'll,
is called an anti-electron.
they are in that.
positron.
He is, the number, he should be green running this system right here, and then he's
On the other hand,
of fun
the
stuff.
photon field is formed of vectors,
Well, it'll let you know some
which are
insights again,
expressed
being the
with
mill
real
guy.
numbers.
Like, it's a hot fucking mess in there all the
They are just
time on
ordinary
1
numbers
common,
which have
2
no phase.
common, 3-footer, 5-footer,
So
crack,
photons
read,
have
blackjack,
no electric charge.
and Jack 5. And so in that color, you don't really know how to use which version of it, but you'd see it shift on a
To
black body
understand how
problem.
electrons
You would see
interact,
it move like
imagine
a
that
danger
we place
noodle,
two of them
you know,
at the
and
start
maybe
of our
you get
quantum
green
field.
or red, well, red and blue, but they basically
In
can
order to schematically
decode
represent the content
to
of the
red and-
universe,
red and green.
it is convenient to use lines to symbolize the movement of particles. A line with an arrow towards the future to symbolize an electron,
Somewhere around here.
with an arrow towards the past in the other direction to symbolize a positron, and a wavy line to symbolize a photon.
Oh, I had a bunch of pens.
To
all
describe
different
how
colors.
particles
You know,
evolve,
the mill work
quantum
great like that. But,
electrodynamics
you know, when you want
allows
to
our
have the
two
caution
fields to
lines in an
interact
area, it's like
using
always around
interaction
that rail.
vertices.
Or those two guys
An
or one
interaction
guy in that
vertex
thing. It's like that
involves a
swing
photon
area is like backing up a skid
and
steer.
two particles
You know, when
of
you're
the
in that,
electron type.
the same thing is, yeah, you
These
almost
can
clip
be
your lines.
electrons
That happens
or
a lot when
positrons,
you're used
depending
to
on their orientation
being a
with
skid steer.
respect to
So I'm
time.
gonna throw you in that box and it'll be like beep beep.
Such
you
a
know?
vertex
So
can symbolize an
the
electron
photon on
which
that
emits a
could
photon,
be the visual
an
on
electron
this
which absorbs
index.
a photon,
If I've limited you to be on the
a
same line as
positron
me
which emits a photon,
inside
or
here.
absorbs a
Now,
photon,
if I got the math books and you'd see the Feynman
or even
diagrams I
an
give you, there's
electron
some
and a
basic
positron
ones.
which annihilate into a photon, or a
Some
photon
real
which
basic
converts
stuff
into an
on a line.
electron-positron
I'm just
pair.
saying between here and here was
All these
F1 plus
interactions
F2.
are
I
allowed,
actually decided to
provided
find
that
a
for
shadow
each vertex, the
in there
overall
once. It might have
momentum
been
of the
7.
particles in
And how many
space
board
and
counts?
time
13
before
packs,
and
12
after
packs.
the interaction
And you go over those
remains the same.
averages. And you'd say from there,
electric
the
charge
rough
must also
value
be
instead of
conserved.
all the footage
Each
would go to
interaction
the
necessarily
lowest
has an
index
arrow
on
that
what that
enters,
is.
and
So
another that leaves
the smallest
vertex.
value of all footages that could be there roughly. Now, there might be some
By allowing our
weebles
two
in that
electrons
number
to
that
interact
if
with
I
these
use
kinds
it
of
a million
vertices,
times, it'll start
we
to
can then
redshift
imagine a
on
whole
me.
variety of
Or it
different
may not,
scenarios.
you know, that depending on
In the simplest scenario, the two
what
electrons
gravity
continue in a
might
straight line. In another, more interesting scenario, the
Thumbs
two
up.
electrons exchange a
You know.
photon, which acts as a messenger carrying part of the momentum of the first electron
both on
to
line
the
for the
second
day.
electron.
It comes up to you first on the line because you are on that line.
It is
You
important
know, and then
to
you
note
switch
that
off
particles
the
behave like
diagram,
waves.
right? One common,
They can
two
be
common,
exchanged along
the
one
shorter
direction,
one, the longer
even
one,
though they carry a momentum
tread
which is oriented
operations,
differently.
who's what doing what operation
That
in the
way,
stone mill,
in some
which for
scenarios,
stables,
the exchange will bring the two electrons closer.
will eventually converge. You know, that's why I took the front there, you took the front there. It makes sense with the arguments. You
And
bring
in
it up
other
to the mass
scenarios,
gap.
the
If there was
exchange
an
will
argument,
push them
because that's
apart.
heat in the pipes. The overall boss is running this middle line. If you can quantify those things back to this original line, would still have that. And again, because
We can then imagine more
all
complex
have
scenarios,
lines about
which
that,
involve
which one
many
was
points of interaction.
broken. It could be compression.
Electrons
There's
can exchange
positive and
several
negative
photons
reasons. Yes, it
at
usually
different
comes up.
places and at different times. Sometimes a photon converts
That's
into an
what the
electron-positron
main model
pair,
was. When you
which
do those
annihilates to form a photon
pallet,
again. We call this a
42s,
loop.
stacking them up before you
An
do the
electron
full
can also emit and then
bottom row, so
reabsorb
that
a
way you're not
photon.
fighting it. It'll reabsorb that and geodesics
As
it
long as the
instead of
overall
just the hard
momentum
line of
and
lay down
electric charge are
42,
preserved.
get a bunch of 9-footers in there,
All
compensates
imaginable
for all those
scenarios,
9-footers,
an infinity of more or less
or
complex
7-footers
possibilities
while you're
can
setting
occur.
up on all those commons. Or, well,
And if we
X's.
stop the evolution of the field after a
look
certain
down the
time
line,
to
and
look at the outcome
that's still
of each
1.
scenario,
To you it
we
does,
sometimes
but
find
the
our two
rookie,
electrons, and sometimes more particles, with some having appeared between the
they got
initial
lots of lines
and
laying
final
through
instance.
each other, lining up packs, and how
Each
that
of these
starts
scenarios,
to
which
skew
start
or-
from an initial situation and reach a final situation,
So-
is called a Feynman diagram.
It's more about nowadays.
Feynman diagrams
Not too far
transcribe
off,
the different
but-
possible evolutions of our quantum fields from a given initial situation.
You know, when I give you keys to Solomon here, you know, when I say that's the
Apart
challenge
from the
coin,
initial and final
that's the
particles,
Z coin that
which
says,
are
well,
real
if you mean you
particles
get
can be
that, then it's worth
detected.
me to take the
The
time to show
particles
you
that
that
act
nickel
as
right now,
messengers
which takes a
within
little off
these
the line for
diagrams
me, or
are said to be
operating a
virtual.
loader, or how
These
the
are particles that
clean and
cannot be
red program
detected,
works
and they
out
can
front,
exhibit
the
some
chipper,
rather strange
and you want to do a
properties.
technique to it, pull all the stuff off, the
They
long
only
stuff,
serve as
clean it out, make
intermediaries
sure there's
to
nothing
describe how our
slapping
two
down range
electrons
like that,
interact at a
if you got
distance.
something that does, and then you work on the chips. Just look 'em all in a
Mathematically,
pile.
each scenario,
Do it the
each Feynman
fastest
diagram
that way
corresponds
every
to a very
time. It's
rigorous
the
equation.
safest variable
And virtual
on
particles are only a
describing
way
the
of
steps
interpreting
of that thing, but it might
certain
have
parts of the
weird
equations.
parentheses. The whole action of that just pulling out the wood
That
pieces
said,
is this, because
although they are only
watch out for
intermediaries
shit
resulting
slapping
from our
around.
mathematical model, it is essential to consider these virtual particles
Catch you on the next one.
because